Hello, in this video I will demonstrate a very quick test on PH20 with a 1.6 inch diameter gauge ring. So I created a program in Modus to let PH20 to measure this gauge ring with different measurement strategy. So you can see I set up a manual alignment, but to save you some time I will run directly from the DCC alignment. So you can see how PH20 measures features. So let's start directly from the DCC measurement. So we got a warning and I'm gonna click on OK. Now you will see the first loop, the PH20 is measuring this gauge ring in a 3-axis movement, just like a PH10. It is measuring 8 points inside a 1.6 inch diameter and will report diameter, circularity, and X and Y coordinates. Now the second round I will use just a head touch on PH20 to measure 8 points and then report again. And in the next 3 loops you will see it is measuring the ring with the PCS 5-axis movement, but with the 3 different settings in Modus. So it will have a different height manipulation in terms of where and what height the probe will touch the point. So you can see this is a much lower manipulation on the 5-axis touch. Okay, now after measuring the ring as a circle, I will measure this ring again as a cylinder, still in 3-axis movement with 16 points at 2 different levels, so 8 points on each level. So this simulates the same as PH10 measuring a cylinder. So now I finished the first round, and the second round I will let PH20 use the head touch only to measure the same cylinder at the same level, 8 points for each level, and then report the diameter, cylindricity, and X and Y. Now for the next 3 loops it will use PCS 5-axis movement to measure the same setting ring and report diameter, cylindricity, X and Y. So this is also a PCS measurement with a different manipulation in Modus to lower the probe body down. And I'm even trying even lower setting, so you can see how much angle the probe is in relationship to the ring. And now the last loop, I'm using a different strategy to measure the cylinder. Instead of using 2 levels of the circle measurement, this time I'm using the line technology to measure the cylinder at 8 different lines equally spaced around the ring. So now we've done the measurement, and let's take a quick look at the result. Now first you have to know that I'm actually using imperial, and I set up ±2/10 as a tolerance for reference, but I output the 5th decimal places. So if you see those errors, don't fool yourself. It is not really a 10th, it's actually a 20 millionth, 30 millionth. So You have to be careful when you look at these results. They are really small deviations. So we are measuring the same feature with totally different probe angles, and in circle and as cylinder. You can see the difference is so small. This shows how much accuracy you can get with PH20 inferred calibration. So you can see all the deviations are very small. Mostly are within a tenth. So let's run the program to the end so we can create a RTF report, and then we can take a closer look on the numbers. So here is the RTF report, and let me make it bigger, and you can see clearly on these details. So one thing you need to know, if you're not very familiar with PH20, that with PH20 you don't have to calibrate all those individual angles. You only have to calibrate a few different positions as an inferred calibration, and then you can use those angles anytime, anywhere you want. And you can see all these results showing a very high accuracy, especially even with a cylinder that we measure at a very low position, you still gain very high accuracy. So you can see how fast, accurate, and flexible that PH20 is in terms of measuring features. So this is just give you a very quick idea how PH20 works, and I will have more videos in details and in depth to showing you how to use Renishaw PH20 5-axis. I hope you can watch those videos and learn more about Renishaw PH20 technology.